Hello everybody, get ready to do lesson 4.2 part 2 of pre-calculus math today. If you have any questions, email me here. If you need note-taking guides, other PowerPoints or video, contact me here as well. So today we're going to do 4.2 part 2 of trigonometric functions, unit circle. 36 points in this class worksheet. There's no notebook taking on this part of the lesson today. So moving on to page 14, domain and period of sine and cosine. The domain of the sine and cosine is a set of all real numbers. To determine the range of these two functions, consider the unit circle shown here. So here again is our unit circle. We have -1 and is less than or equal to y, and y is less than or equal to 1. So here's your range here. And then here's your domain on your unit circle, -1 less than or equal to x, x is less than or equal to 1. So here's your range, and then here is your domain. Here's your domain, here's your range here. So because r equals 1, our radius equals 1 here, it follows that sine t equals y, cosine t equals x. Moreover, because xy is on the unit circle, you know that -1 is less than y, y is less than 1, same thing for x. So the values of sine and cosine also range between -1 and 1. So we know our values here for y are these values, and then sine t will be between those two values. Then -1 again for x values are between -1 and 1. And then for our cosine, it would be -1 and 1. That is your domain and range here for using the unit circle calculations of figuring our trig functions. Adding 2 pi to each value of t in the interval 0 to 2 pi completes a second revolution around the circle as the unit circle is shown. So 2 pi is one complete revolution here. Then if you want to go beyond it, you just add like 2 pi plus pi over 4, etc., etc. Then 3/4 pi would be, if you want to go one complete revolution and then 3/4 pi more, you just add 2 pi to your 3/4 pi. The values of sine t plus 2 pi and cosine t plus 2 pi correspond to those of sine t and cosine t. Similar results for repeated revolutions, positive or negative, around the unit circle. This leads to the general result of sine plus 2 pi n equals sine t and cosine t plus 2 pi n equals cosine t. For any integer n and real number t, functions that behave in such a repetitive or cyclic manner are called periodic. Definition of a periodic function. A function f is periodic when there exists a positive real number, c, such that f of t plus c equals f of t. For all t in the domain of f, the least number c for which f is periodic is called the period of f. So it follows from the definition of a periodic function that the sine and cosine functions are periodic and have a period of 2 pi because they have one complete revolution on the unit circle. A function f is even when f of negative t equals f of t, and is odd when f of negative t equals the negative of f of t. Of the 6 trig functions, 2 are even and 4 are odd. So let's see which ones those are. Even and odd trigonometric functions. The cosine and secant functions are even. Cosine of negative t equals cosine t. And then the secant of negative t equals secant t. The sine, cosecant, tangent, and cotan functions are odd. So in that situation, sine of negative t would equal the negative of sine t. And then the cosecant of negative t would equal the negative of cosecant t. Tan negative t would be the negative tan t. And then cotan of negative t would equal the negative cotan. Okay, so getting into our example here of using the period to evaluate sine and cosine, we have 13 pi over 6, which is 2 pi plus pi over 6. So to evaluate that, we have sine of 2 pi plus pi over 6, which would equal the sine of pi over 6, which would equal 1/2. And then the negative of 7 pi over 2, which is the same thing as the negative of 4 pi plus pi over 2. In that situation, you have the cosine of negative 4 pi plus pi over 2. Negative 4 pi would be 2 negative revolutions on your unit circle there. And then you go back positive pi over 2, which would equal 0. That would be your 90-degree mark up there. So at that point on your unit circle, cosine pi over 2 would equal 0. And then for sine t equals 4 over 5, we're going to find out that the sine for that, sine negative t, would equal the negative of 4 over 5 because the function is odd. 4 over 5 is, I think it's about 25 degrees, I think. So it'd be 25 degrees positive, and then if you take the negative of 4/5, it would put it down in quadrant 4, and it would make it a negative for that because the sine function is an odd function. Okay, so to do this here, we need to evaluate the trig function using its period as an aid. So how many periods are in 5 pi here? So we have 2 pi per revolution. So we would have 2 revolutions plus a pi here. So cosine 4 pi plus pi would be 2 revolutions plus pi, which would put it at the 180-degree mark on a unit circle and put it over here on your unit circle. And at that value, your x would equal -1. So that would be cosine 5 pi. Then cosine 8 pi over 3, how many revolutions in the unit circle? So it would be 2 pi plus 2 pi over 3. So it would be 1 revolution plus 2 pi over 3, which would make it at the 120-degree mark is where it would be. So cosine 8 pi over 3 would equal cosine 2 pi plus 2 pi over 3, which would equal cosine 2 pi over 3, which would be a -1 over 2, would be your 2 pi over 3, would be your cosine 8 pi over 3 would equal -1 over 2. And then again, here are values here. Cosecant t would be 1 over y, would be the square root of 2. And then secant t would be 1 over x. And these are for other triangles here. You can use a calculator to evaluate trig functions. When evaluating a trigonometric function with a calculator, you need to set the calculator to the desired mode. So when you go into your calculator into mode, you'll see degrees or radians. Most calculators do not have keys for the cosecant, secant, and cotan. To evaluate these functions, you can use the x1 key with their respective reciprocal functions, sine, cosine, and tangent. For example, to evaluate cosecant pi over 8, use the fact that cosecant pi over 8 is the same thing as 1 over sine pi over 8, and enter the following keystroke sequence in radian mode. So you go sine pi divided by 8, double closure here in your parentheses, x to the 1, and then enter, and then you should get this as your result here from this keystroke entry on your calculator. So let's go into another example here. Example 3 using a calculator. So we're going to do some of this entry here into a calculator, sine 2 pi over 3. So the way we would enter that, first of all, your mode should be radian, and then your entry here would be sine, and then 2 pi divided by 3, open parentheses, close parentheses, and enter. and you should get this on your calculator for sine 2 pi over 3. And then for cotan 1.5, again radian mode, you would open parentheses tan, and then 1.5, second open parentheses here, 1.5, close, close, x to the negative 1 power, and then you hit enter, and you should come up with this number here for taking the cotan of 1.5. Okay, let's try this now. Use the calculator to evaluate the trig expression. Round your answer to 4 decimal places. So let's try cosec at 1.3 and then cotan 3.7. So cosec at 1.3, to get that, you should get 1.0378. So cosecant is the reciprocal of sine. So it'll be 1 over sine 1.3, and you should get this here. And then cotan is the inverse of tangent, so you should go 1 over tan 3.7, and you should get this number here, 1.6007. And that is your lesson for today of pre-calculus math. Email me here for questions or other course materials or tutoring. Thank you very much.